Hello guys and welcome back to our channel. Before we go ahead, do well to share, like and subscribe to our channel so you get updates on any more videos we upload in the coming days. And as promised in our last video tutorial on algorithms, and we are going to solve a very interesting problem this time around using the recursive technique which we learned in our last video. I remember that in our last video, towards the end of it, I gave some problems which you were to solve at home as assignments using the recursive technique. Those included the Fibonacci sequence, the power function, and Hanoi's tower. So in this particular video, we are going to tackle the Hanoi's tower problem. Together we are going to go through the problem statement, and I am going to go through the solution step by step and slowly so you understand the solution. So this is the problem statement of the Hanoi's tower problem. Let's consider three vertical pegs labeled as follows: source, destination, and intermediate pegs. On the source peg, there are n disks placed in decreasing order of their diameter. The disc at the bottom is the largest one. We want to move all discs from the peg source to the destination by using the intermediate peg such that the following constraints are satisfied. On the destination peg, the discs are placed in the same decreasing order. A disc can never be placed on a smaller disk. Read through the problem again. How do you move the disks, all of them, from the first peg to the last peg, that is from the source peg to the destination peg, with all the disks in the same order as they were in the source peg? Remember the problem statement: no large disk on a smaller one. And remember, you can only remove the topmost disk at a time. You can't start from the bottom, neither can you start from the middle. What would you do? Think out of the box. If you need more time, you can definitely pause the video to think till you can finally figure out something. Just compare your solution to what we are going to have here in a moment in order to see what you might have missed or what you can add to what you already know. Okay, so here is our solution. In order for us to solve this problem, the first thing we have to do is remove the topmost disk and place it in our destination peg. We remove the second disk and we place it in our intermediate peg. Reason being that the disk below the first one is larger, and so we cannot place it on the topmost disk. So what we do next is we move our disk which is in the destination peg back to the intermediate peg. So it begins to appear in the same order in which it was in the source peg. We now move these two disks back to the destination peg. We take the next disks from the source peg to the intermediate peg. We get the two disks which we have the destination peg and place on that one in the intermediate peg. We repeat the same process over and over until all n disks have been transferred onto our destination peg. As simple as that. So what do we call what we have just done? It's simply called recursion. That's the basic idea of solving this problem. Simply by moving n-1 disk from the source peg to the intermediate peg using destination peg as an intermediate peg, you move the largest disk from the source to the destination, you move the n-1 disk from the intermediate peg to the destination peg using the source as intermediate peg. This idea is very easy in a recursive algorithm. As you can see, the algorithm here we have on the board. In order for you to successfully solve this problem, if you were to write it in a computer program, you first of all have to declare your variables, that is n, the source, destination, and integer pegs. You initialize a certain value, maybe n equals to 1. Then you start moving from the source to the destination, and you follow the process which we just explained above, and the problem is solved. So clap for yourself, you just solved the Hanoi stopover problem. In our next video, we are going to touch much theory on structured and unstructured programming. Thanks for watching, and we hope you're finding these videos very useful and helpful, and hope they are helping you as well to study better. Much love from the Lengval team, and goodbye.